There is a town in Italy where 82,000 people go to sleep every night sitting directly on top of a magma chamber that once produced an eruption powerful enough to lower global temperatures for years, bury 3/4 of Europe in ash, and possibly help wipe out the Neanderthals. That town just shook. Buildings cracked. A cliffside gave way and crushed parked cars. People were pulled from rubble. And here's the part almost nobody is talking about correctly. The scientists monitoring this volcano have been warning for over a year that the ground itself is physically rising, inch by inch, month by month, and nobody knows for certain whether this earthquake is the release valve or the warning shot. By the end of this, you're going to understand exactly why this patch of Italian coastline might be the single most dangerous, most misunderstood, most quietly terrifying volcanic system on the planet. And you're going to understand why the headlines got the story almost completely wrong. Let's start with what actually happened, because the actual event and the reported event are two different animals. A magnitude 4.7 earthquake struck southwest Italy, right at the edge of Naples, right beside the Campi Flegrei volcanic complex. Dozens of people were injured. Homes cracked open. Rock slides tore down hillsides and flattened cars beneath the debris. Every major outlet picked it up within hours. And one detail kept repeating across headlines. This, they said, was the most powerful earthquake to strike the region in 40 years. That claim is technically false, and understanding why it's false is the first clue in this whole story. Just 7 months earlier, in March, a 6.0 magnitude earthquake struck less than 5 kilometers from that exact same spot. A 6.0 earthquake releases roughly 32 times more energy than a 4.7. That's not a small gap. That's the difference between a firecracker and a stick of dynamite. So, why didn't the March quake make global news the same way? Because it was deeper, and depth changes everything in seismology. A deeper earthquake spreads its energy through more rock before it reaches the surface, like dropping a stone into a swimming pool versus dropping it into a bathtub. The March 6.0 barely rattled windows. The recent 4.7 was shallow, maybe 2 to 3 kilometers down, and shallow quakes hit like a hammer directly under your feet. So the headline should never have said most powerful. It should have said most damaging. Those are two completely different measurements, and mixing them up isn't just sloppy journalism. It's the kind of error that makes people misjudge real risk. And if we're actually being precise about most powerful earthquake in the region, we have to go back further and further north. In 2016, a 6.8 magnitude earthquake struck near Norcia, about 225 kilometers north of Naples. That quake didn't just crack a few buildings, it flattened entire towns. Hundreds were injured. Remarkably, there were 0 fatalities because Italian seismologists managed to issue evacuation warnings 1 to 2 days before the main shock, based on foreshock activity. That 2016 event remains the strongest earthquake to hit the broader Italian region in 4 decades. The recent Campi Flegrei quake wasn't even close to it in raw power. It was close to it in terror because of exactly where it happened. And that's the real story here, not the magnitude, the location. Picture the epicenter, now zoom out. What you find isn't just a random Italian coastal town. You find a caldera, a vast collapsed volcanic crater roughly 12 to 15 kilometers wide, formed by 2 of the largest eruptions in European history. The first, the Campanian ignimbrate eruption, happened around 39,000 years ago and is considered one of the largest volcanic events in the last 200,000 years on Earth, ejecting an estimated 200 to 300 cubic kilometers of material and possibly contributing to a volcanic winter that some researchers link to the decline of Neanderthal populations across Europe. The second, the Neapolitan yellow tuff eruption, struck around 15,000 years ago, smaller, but still classified at a VEI6, the same explosive category as Mount Pinatubo in 1991, an eruption that cooled the entire planet by roughly half a degree Celsius for 2 years. That's what this town is built inside of. Not next to. Inside of. Here's the detail that should stop you cold. If you pull up satellite imagery of Campi Flegrei, you'll see homes, apartment buildings, entire neighborhoods constructed directly inside smaller nested craters within the larger caldera, spatter cones and collapse pits from more recent, smaller eruptions. Streets curve around the rims of ancient volcanic vents. Families raise children on the floor of what used to be an active eruption site. This isn't ignorance. Naples has been inhabited for nearly 3,000 years. People built there because the volcanic soil is extraordinarily fertile and the coastline is beautiful. But it means roughly 500,000 people currently live inside the designated red zone. The area Italian authorities have mapped as facing the highest risk if the system erupts again, and the greater Naples metropolitan area, home to about 3 million people, sits close enough to feel catastrophic consequences from a moderate eruption, let alone a large one. Now, here's where the science gets genuinely strange, and where most people, even Italians, misunderstand what's actually happening under their feet. Campi Flegrei doesn't behave like a typical volcano. It doesn't have a single cone building pressure toward one dramatic explosion. Instead, it does something called bradycism, a slow, rhythmic rising and sinking of the entire caldera floor, driven by pressure changes in a shallow hydrothermal system sitting above the deeper magma reservoir. Think of it less like a bomb and more like a chest breathing. In the early 1980s, the town of Pozzuoli, sitting almost dead center in the caldera, rose nearly 1.8 meters in just 2 years. An entire town lifted almost 2 meters into the air over 24 months. Streets buckled. Buildings had to be evacuated. Then, just as mysteriously, the ground began sinking again, and it stayed relatively quiet for 2 decades. Since 2005, it has started rising again. And since 2012, that rise has been accelerating. By recent measurements, the cumulative uplift in Pozzuoli since this current cycle began has exceeded 1 meter, roughly the height of a kitchen counter, permanently lifted into the sky beneath an entire town, centimeter by centimeter, year after year. Scientists at Italy's National Institute of Geophysics and Volcanology, INGV, monitor this with GPS stations, accurate to millimeters and satellite radar interferometry, a technique called INSAR that can detect ground deformation from space smaller than the width of a coin. And what those instruments have shown consistently is that the rate of uplift has been increasing, along with the frequency and magnitude of earthquakes. This is not subtle. This is a caldera visibly, measurably swelling, and earthquakes are the direct fingerprint of that swelling. As magma-heated fluids and gases push upward from depth, they fracture the brittle rock above them, the same way pressure building inside a sealed container eventually splits the seams. Each fracture releases seismic energy. In 2023 alone, INGV recorded thousands of small tremors beneath Campi Flegrei, most too small to feel. But the trend line matters more than any single quake. The frequency has been climbing. The maximum magnitude has been climbing. In May of 2024, a 4.4 magnitude quake struck the area, at the time being called the strongest in roughly 40 years. Less than a year later, we're looking at events pushing past that number. That's not noise, that's a pattern, and patterns in volcanic seismology are exactly what forecasters watch for. because they often precede eruptions elsewhere in the world by months or years. Does that mean Campi Flegrei is about to erupt? No, and it's critical to be precise here because sensationalism helps nobody. Increased seismicity and ground uplift indicate the system is actively pressurizing. They do not provide a countdown clock. Volcanoes can sustain unrest like this for decades without erupting. Campi Flegrei has been in some state of unrest on and off since the 1950s, but scientists have been explicit in their warnings. INGV and Italy's Civil Protection Department updated the official evacuation plan for the red zone in mid-2024, and researchers publishing in journals like Nature Communications and Geophysical Research Letters have flagged that the crust beneath Pozzuoli is now measurably weaker and more fractured than it was a decade ago, meaning it may take less additional pressure to trigger either a larger seismic event or, in a worst-case scenario, an eruption. And here's the detail that deserves far more attention than it gets. Unlike a volcano such as Kilauea in Hawaii, which tends to give days or weeks of escalating warning signs through lava lake behavior and gas emissions, researchers studying Campi Flegrei's eruptive history suggest this system could transition from unrest to eruption far more abruptly. Some past eruptions here appear to have had only short precursory phases. There may not be a slow countdown. There may just be a threshold, crossed quietly, followed by an explosion. Now, let's zoom out even further, because Campi Flegrei is not alone. It's not even unusual for this part of Italy. If you trace a line north from Naples, you find an entire chain of massive volcanic complexes strung along the interior edge of the Italian peninsula. Colli Albani, just southeast of Rome, a caldera of comparable size to Campi Flegrei, containing smaller water-filled craters within it. Further north, the Sabatini volcanic complex, largely filled by lakes today, but still showing spatter cone structures on its northeastern edge. Continue north and you hit Vico, Volcini, each one a dormant giant recognized by volcanologists and cataloged by the Smithsonian Institution's Global Volcanism Program. And near the top of this chain, satellite topography reveals an oval depression roughly 40 miles long and 20 miles wide, ringed by at least 9 smaller volcanic centers, a formation that, by scale alone, rivals some of the most infamous supervolcanoes on Earth. For comparison, Toba, the Indonesian supervolcano whose eruption 74,000 years ago is theorized by some researchers to have caused a genetic bottleneck in early human populations, measures approximately 100 kilometers by 30 kilometers. The Gakkel Ridge volcanic system beneath the Arctic Ocean spans roughly 60 by 27 miles. Long Valley Caldera on the California-Nevada border, one of the most closely monitored volcanic systems in the United States, measures about 20 by 10 miles. That unnamed formation in northern Italy sits comfortably within that same size class. It has never been officially classified, but geologically the shape doesn't lie. Why does this chain of giants exist specifically here, running like beads on a string down the spine of Italy? The answer is tectonic, and it's genuinely elegant once you see it. Italy sits at the collision point between the African and Eurasian tectonic plates. Along the southern and eastern edges of the peninsula, the African plate is subducting, sliding beneath the Eurasian plate, diving down into the mantle. That subduction curves around the boot of Italy like the letter J and connects eastward toward Turkey. As the subducting slab descends, it releases water and volatiles into the mantle wedge above it, lowering the melting point of the surrounding rock and generating the very magma that feeds this entire volcanic corridor. It's the same fundamental mechanism that built the volcanoes of the Pacific Ring of Fire, just compressed into the Mediterranean on a smaller, but still monstrous, scale. Here's a genuinely strange thread worth pulling on. one seismologists take seriously when analyzing regional stress transfer. In the days surrounding this earthquake, a trail of moderate quakes in the magnitude 4 to 5 range appeared to march across the Atlantic-facing boundary of the plate, from the mid-Atlantic ridge zone through the western Mediterranean toward Italy. When energy moves through a plate boundary like this, it typically has to go somewhere once it hits a geological dead end. In Italy's case, that means two possible outlets. Either the stress bleeds outward through the volcanic corridor stretching toward the Azores in the mid-Atlantic, or it barrels straight across the European continent toward the English Channel in the Arctic. The way a car maintains momentum through a curve instead of following the bend in the road. Watching both of those zones for follow-up activity in the days after an event like this isn't superstition. It's basic elastic rebound theory, the same physics that governs how stress redistributes across a fractured, interconnected plate system. Let's bring this back down to human scale, because all of this geology means nothing if you don't understand what it actually feels like to live there. Imagine your house sitting inside what used to be an eruption crater. Imagine your government issuing an official update to your neighborhood's evacuation plan, as Italy's Civil Protection Department did in June of 2024, not as a drill, but as a direct response to measured ground deformation happening beneath your street. Imagine walking past a hillside and seeing plainly visible the rock scar from a landslide triggered by a 4.7 earthquake, cars beneath it crushed like soda cans. That's not a hypothetical disaster movie scenario. That is Pozzuoli, right now, in real photographs from this week. And there's a psychological trap buried inside all of this, one worth naming directly. Because Campi Flegrei has been acting up for so many years without erupting, complacency creeps in. Locals joke about it. Life goes on. Cafes stay open along the waterfront just a few hundred meters from monitoring stations recording continuous ground swelling. That's not irrational. Humans adapt to chronic risk remarkably well, sometimes too well. The Norcia earthquake in 2016 proved that early warning based on foreshock patterns can save lives, hundreds of injuries, 0 deaths. But Campi Flegrei may not offer that same courtesy. If the system does eventually erupt, some volcanologists studying its eruptive history warn it could happen with far less lead time than a slow-building eruption like Mount St. Helens in 1980, which gave 2 months of visible warning before its catastrophic lateral blast. So, what would an eruption actually look like if the worst-case scenario ever unfolded? Nobody is predicting an eruption on the scale of the 39,000-year-old Campanian ignimbrite event. That was one of the largest eruptions in the last 250,000 years of Earth's history, and events of that magnitude occur on timescales of tens of thousands of years, not human news cycles. But even a moderate eruption, smaller than either of Campi Flegrei's prehistoric super-eruptions, could still displace hundreds of thousands of people, disrupt one of Italy's busiest ports, and blanket the Naples metropolitan area, home to roughly 3 million people, in ash. Aviation across southern Europe would face the kind of disruption seen in 2010 when Iceland's Eyjafjallajökull, a fraction of Campi Flegrei's size, grounded flights across the entire continent for days. Now, scale that up to a volcanic system with a documented history of VEI-6 and VEI-7 eruptions, and the regional consequences become genuinely difficult to overstate. This is why the scientific community keeps sounding the alarm, even when the public conversation keeps drifting towards simpler questions like, was this earthquake a record? The record-breaking framing misses the point entirely. The point is that an entire volcanic system beneath one of Europe's most densely populated regions is measurably, continuously inflating, And every earthquake is a data point in that inflation, not an isolated news story. There's one more thread here worth mentioning, uncomfortable as it is, because it touches on how information about natural disasters sometimes gets distorted after the fact. Years ago, a warning was issued ahead of a significant earthquake in southern Italy, and when the quake struck, it caused real damage and real injuries. But in the aftermath, public records and media reports around that event became inconsistent, with some sources downgrading the reported magnitude days later in ways that didn't match the original damage reports. Whether that reflects standard scientific revision, which does happen as agencies refine preliminary magnitude estimates using more complete seismic data, or something messier involving how forecasting controversies were being politically handled in Italy at the time, is genuinely difficult to untangle years later. What it should teach any of us is simple. Treat the first reported magnitude as preliminary. Treat damage reports and structural evidence as more reliable indicators of true severity than a number alone, especially in the first 24 to 48 hours after any earthquake. Zoom out one more level, because Campi Flegrei isn't happening in isolation on planet Earth right now. This week alone, a 5.6 magnitude earthquake struck off Vancouver Island along the Juan de Fuca plate boundary, the second event of that size in that specific location within a couple of weeks, after months of relative quiet. Central Texas has seen a cluster of earthquakes tied to oil and gas extraction operations, including one reaching magnitude 5.0, a rare size for that region historically. Northern California has shown renewed activity near the Clear Lake volcanic field, an area where geothermal energy companies actually drill directly into volcanic heat to generate power, turning subterranean steam into electricity for the grid sitting practically on top of the San Andreas Fault. None of these are connected to Campi Flegrei in a direct physical sense. Plate boundaries don't transmit stress across ocean basins that quickly, but they illustrate something important. We are living through a period of globally elevated seismic attention, not because the planet has suddenly become more dangerous, but because monitoring networks, satellite deformation data, and public access to real-time earthquake feeds have made every rumble visible in a way that simply didn't exist even 20 years ago. That visibility is a gift if you use it correctly. It's also easy to misuse if every moderate earthquake gets inflated into the big one for clicks. So here is the actual, sober scientific picture, laid out plainly. A 4.7 magnitude earthquake struck near Campi Flegrei, shallow, destructive, injuring dozens, but not the most powerful regional earthquake in 40 years. That distinction still belongs to the 2016 Norcia quake at magnitude 6.8. It was, however, likely the most damaging earthquake in that specific city in recent memory, a distinction that matters more locally than globally. It occurred atop a caldera that has been inflating since 2005, accelerating since 2012, with over a meter of cumulative uplift recorded in Pozzuoli, a town of tens of thousands of people living inside an ancient eruption zone. The broader region sits along an active subduction boundary that has built an entire chain of calderas and supervolcanic structures stretching from Naples to the base of the Alps, one of which remains geologically massive enough to rival Toba, yet still lacks formal classification. And while an eruption is not considered imminent by any monitoring agency, the trend in seismicity, ground deformation, and crustal weakening is one that professional volcanologists are watching with genuine, documented concern, not manufactured panic. Here's the question worth sitting with. If roughly 500,000 people can live inside a volcanic caldera for generations, raise families, build churches, run cafes along the waterfront, all while the ground beneath them measurably rises and falls like a slow, geological heartbeat, what does that tell us about how humans actually calculate risk? We are extraordinary at responding to sudden danger and remarkably bad at respecting slow, creeping danger, the kind that takes decades to reveal its full shape. Climate change works this way. Aquifer depletion works this way. And Campi Flegrei works exactly this way. 1 centimeter of uplift at a time, one small earthquake at a time, until one day it either stays quiet for another few centuries, or it doesn't. Nobody can tell you which outcome is coming. Not INGV, not the world's leading volcanologists, not any predictive model currently in existence. Volcanic forecasting, unlike weather forecasting, still cannot give you a reliable countdown. What can be told to you with total certainty is this. The ground beneath Naples is not the same ground it was 20 years ago. It's higher, it's more fractured, it's under more pressure. And every earthquake like this one is the sound of that pressure finding somewhere to go. So if you're watching this from Italy, especially from anywhere near that red zone, this isn't meant to frighten you into panic. It's meant to do the opposite, replace vague dread with actual understanding. Know your evacuation route, the one your Civil Protection Department has now updated. Know where your nearest designated safe zone is. Keep a small emergency kit, a change of clothes, sturdy shoes, a flashlight with fresh batteries, a basic first aid kit, something for sanitation, food and water that doesn't need refrigeration. None of it needs to be expensive. None of it needs to sit untouched in a closet you forget about. It needs to be somewhere you can grab it in under 30 seconds. Because if this system ever does move from unrest to eruption, the transition might not give you the days of warning that Norcia's foreshocks gave the world in 2016. It might give you far less. And if you're not in Italy, if you're watching this from thousands of miles away with no personal connection to Pozzuoli or Naples or the Bay of Bagnoli, ask yourself this instead. Somewhere near you, whether it's a fault line, a floodplain, a coastline, or a wildfire corridor, there is almost certainly a slow, creeping, geological or environmental risk that's been quietly building for years. One that everyone around you has simply learned to live beside, the way Neapolitans have learned to live beside a supervolcano. The ground doesn't ask permission before it moves. The only real question is whether you'll be paying attention when it finally does. That's where we leave this one. Not with an answer, because volcanology doesn't deal in certainties, but with a clearer picture than any headline gave you this week. If this kind of investigation is something you want more of, the kind that goes past the panic and actually explains the mechanics underneath it, stick around, because this is exactly the kind of story this channel exists to tell. And if you've got thoughts on what's really happening beneath southern Italy, or if you live somewhere with your own quiet, geological, ticking clock, say so in the comments. Because someone else watching this right now might be standing on the same kind of ground and might not know it.